Hello, and welcome to another challenge. We're on day 23, blue teaming, PowershEllF magic. So let me deploy the machine, and it starts in split view. And okay, the story. One of the administrators with access to the ELF Dome defense system realized that his password file was missing from his desktop. Without the password, he would not be able to log into the mission control panel. McSkitty suspects that perhaps one of the previous phishing attempts was successful. Oh no! McSkitty jumps into action. You need to inspect the event logs to determine what has occurred and see if you can retrieve the password from the deleted text file. So the learning objectives are analyzing Windows event logs to understand actions performed in an attack, recover key artifacts in unencrypted web communications, and utilize PowerShell scripting to recover a deleted artifact. So, PowerShell, what is it? It comes baked into the Windows operating system, a beneficial tool for Windows administrators to automate day-to-day tasks. PowerShell has also allowed adversaries to perform nefarious activities, a concept known as living off the land. So, according to Microsoft, PowerShell is a cross-platform task automation solution made up of a command line shell, a scripting language, and a configuration management framework. PowerShell runs on Windows, Linux, and Mac OS. So as defenders, we can automate commands run in the PowerShell console on each workstation. This is known as PowerShell logging. So when a PowerShell command or script is run, it's logged into the Windows event log system. And there are many event logs generated in a Windows system, but the ones we care about in this challenge are related to PowerShell. So event logs are categorized by providers such as Microsoft Windows PowerShell. Each provider has specific event IDs to identify particular events or actions that occurred on the workstation. The event IDs of interest for us in this investigation are 4103 and 4104. So normally we will use an event viewer, but we're going to use a tool, full event log view, to make this more streamlined. So when we started, we're going to see a large number of logs, but we're going to filter that with the advanced options. And I'm waiting for the machine to boot up so we can start that. Okay, so now we're going to open the tool and it's loading now, and we're going to wait. And as you see, we have a multitude of event logs, different event logs: 4216, 4221, 12, 153, 208, 157. Now remember, we're interested in 4103 and 4104. So we're going to go to the advanced option, and we're going to say a specific time range and local time. And we're going to say 11:10 at 1:00 52 to 11:12 1:00 52. And we're not going to show all the event IDs. We're only going to show specific ones. So 4103, 4104. And we're not going to show all providers. We're only going to show specific providers. and that is PowerShell. So let's do that. Now we have filtered our results just to show event IDs of 4104 and 4103 and related to PowerShell. So now we can also search for by a particular event or an action. So if there's a web-based attack, we could search by HTTP, and here are additional resources if you want to learn more. And if you want to access this machine over remote desktop, here's the IP, username, and password. Excuse me. Now, note, the virtual machine may take up to 3 minutes to load. So if you get into the virtual machine and you notice that the commands are working, give it 5 minutes and then everything should load correctly. Now, what command was executed as Elf McNeely to add a new user to the machine? So we see things here. We see a lot of descriptions, and I just double clicked on one so I can get more information. We're setting a variable. Okay, we're getting children, get child item, and it is the all scripts for PowerShell scripts. And if there's an error, just continue. Okay. So these really don't say anything. And we can go to the description to see if we see anything. Okay. Okay, I'm going to use a hint. It says research CVE 2021 1675. So I'm going to copy this, go to Google, and if we click here, okay, it's a Windows Print Spooler remote code execution vulnerability. Okay, let's click on MITRE. Okay. I'm trying to get more information about this CVE. Okay. So, the Microsoft Windows Print Spooler service fails to restrict access to functionality that allows users to add printers and related drivers, which can allow a remote authenticated attacker to execute arbitrary code with system privileges on a vulnerable machine. The RPC add print driver X function is used to install a printer driver on a system. One of the parameters to this function is the driver container object, which contains information about which driver is to be added by the to be used by the added printer. The other argument, DW file copy flags, specifies how replacement printer driver files are to be copied. An attacker can take advantage of the fact that any authenticated user can call RPC add printer driver X function and specify a driver file that lives on a remote server. This results in the print spooler service spoolserve.exe executing code in an arbitrary DLL file with system privileges. So it looks like we need to find the RPC add printer driver execution in our logs. So it looks like here it's doing some set aliases. We see now that the user is work group system. So now this is system privileges. So now we need to see okay, this is okay. Okay, this is a system. So we need to figure out what McSkitty used to add the printer. Okay. System. Okay, so this is McSkitty. So what is this? Test path. This is testing a path. This is removing. Let's see. No, that's not correct. Okay, maybe. What else? Kernel. Let's see. Let's see if it's RPC. Okay. Okay, let's see. Spool serve. Let's see. Spool. Okay. So I want to say. Okay. Show all. Okay, that's not correct. Get when event. So you're trying to find printer information. Oh, wrong one. let's see. Full service. I don't think that's gonna be it. No. So I'm gonna show all channels and events. That's where we can do. I think this is where we do the HTTP. Yeah. Okay, so. Okay. So we see we're getting the CVE 2021-1675 PowerShell, and we're going to name it grab.PowerShell and use basic parsing, and so it's invoke web request. No, that's not it. So this is McSkitty is Elf McNeely, sorry, is invoking this PowerShell script. And let's see. Okay. Well, we have the answer to this is 10, 10, 1, 4, 8, 96, 4, 3, 2, 1. So now we're admin. So this is the script, send it, and now we have elevated our privileges to admin. Okay, so we see here, this is 728. So let me go. delete.zip. Delete.zip. No. Okay. So 728. Let me go here. I'm going to show all. I'll come back to that one. 728. Okay, we're admin. System.security.secure-string. What is the encryption key? Okay, I see a key. Okay, do I need to keep going? Okay, this is trying to get. Okay. Look, archive resources. I could have used. I didn't know there was a find function. Convert encrypted data. Convert from. Okay. What application was used to delete? sdelete.exe. Okay, so that's right there. sdelete. What was the encryption key used to encrypt the contents of the text file sent to the remote server? So we see here file password.txt, ASCII coding, system security secure string, encrypted data, convert from. So what's the hint? Look for a key in the event logs. So okay, I see that. Okay, the date and time it was deleted. 11/11/2021, 7:26:29 p.m. What's the hint? Search for deleted files. Okay, so it's actually doing this. Send it. Seven 27 44. No. What does it say? Use the advanced option to search for the deleted file. Okay, I did S delete. So 729. 27. Okay, yeah. So this is when it actually executes. So what is the contents of the deleted password file? Okay, what is this? This is a script. Okay, so I'm going to go here. Say password. I don't think it's going to find it. Oh, it did. Okay, password. Oh, Invoke Nightmare? I don't think this is it. Oh, that was it. Okay, Invoke Nightmare. And I did that here because this came from the actual CVE. So this is the actual script. So what user executed PowerShell file to send the password.txt file from the administrator's desktop to a remote server? Admin? No. So we need a, that would be too much like, right? Uh, okay, so let me do HTTP. Okay. So we're trying to find the user. It's not elf. So then this is the invoke nightmare. Oh, admin. So they changed the I to a 1. Now, what was the encryption key used to encrypt the content of the text file sent to the remote server? Okay. Key. Okay, so I'm gonna say show all events. Start at the top. And I'm gonna search for key. Okay. I see this here. Oh, what was the encryption key? So this is the encryption key here. The get bytes. Yeah. Yeah. So this was actually the key, and that's the encryption key. So what were the contents of the deleted password.txt file? And password.txt. Get content. Okay. So this is that. Okay. Okay. Edit decryptor.ps1 with the previously found encryption key and the encrypted value. Okay. Let me go here. Let me open. Okay, so encrypted key goes here. Okay. Encrypted text here. So okay, and I think this is the value here. No, I think this is it here. I think this is the... Well, wait, let me try that, and if that doesn't work, I'll try the other. But I think it might be this, but we'll see. Okay. So let me edit. Let me... Okay, let me see. Okay, so the key's not valid. So that's not the right key. Convert. Okay, what was going on? So it seemed like it. Okay, so that's ASCII. That's a secure. It sets that up. And this is the key. Because it's saying okay. I don't think this is it. We need to find the encrypted. Okay. And the encrypted value. Okay. Okay. So we got the encryption key and the encrypted value. So Okay, I'm going to look for encrypted. Find next. Okay, so that's the only one. Okay, S delete. Oh. This. Okay, so that's the only one. So that's password. That's the ASCII. Okay, that's the key. That's not it. Okay, so this is not right because this is this key. So we need to find the encrypted text. Okay, so if I go back to encrypted, let's see if I find something for convert from. Okay, so this is the convert from secure string, and then this is the key. What's this? So that matches this here. So that's not what we're looking for. Use the previously found encryption key in the encrypted value. Where is the encrypted value? Okay. So post and then the body was the encrypted data. So that's what I actually put here. The body is this. So I put that and it didn't like it. Because here, so when we invoke the web request, the URL post body is the encrypted data. So going here, URL post body. So it didn't like that. Let me try this again. Yeah, it didn't like it. Why? Is this not needed? Here's the value. It's here. This is the value. So let me close. Let me reopen. Okay, so that, and then encrypted. Here's the body, here's the value. Yeah, why does it not like this value? That was the key. Okay. We get the bytes. Oh, no. Did I have one? Oh, I had an extra character. Oh my god. That's why you gotta make sure, triple check, double check. I had an extra character, and that's why I didn't read. So I had an extra E that was not needed here inside the get bytes. And then I had originally used this as the encrypted value, but that was just the key, and the encrypted value was this here. So I was right the second time, it was just my key was off. So now mission control, let it snow, let it snow, let it snow. So okay, and that's it. So, whew, this was a difficult challenge because blue teaming is not my jam. I really haven't done a lot, but it is interesting. As you can see, the devil is truly in the details, so you have to pay close attention. So I had it right the second time, except I had added an extra character in my key, and that's why it didn't read. So I hope you've learned a lot in this video. I have, and I can't wait to see you in the next one. Have a good day. Bye.